Oh. So let this be the density of sheet is sigma. This is the x-axis, this is y-axis, and this is the origin. What is the field strength at a distance z? Find gravitational field strength on the z-axis at a distance z. How to do this? Because earlier we talked about only the negative density or something like only in the spherical cavity, no? Like this in a sheet, I'll make a hole. So what you have to calculate is find the field strength on the z-axis at a distance. Okay, let's do one thing. This will be 3r due to large sheet with circular hole of radius r. Okay, now go back. Do we have any formula for large sheet? Anybody? Any formula is there or no formula we have to derive? I think already we have discussed this also. So what is the formula for large sheet? Is anybody formula?
2 pi sigma g.
2 pi sigma g. Okay, now this is 2 pi sigma g. How to, can we use, shall we integrate? Because there's like a disk is there. No need of any integration. Huh? Just stick on to the small basics what we have 2 pi sigma g. Okay, yeah, thank you all of you. Now we'll get into this one. Shall we use again superposition principle? I'll in a sheet without hole, I'll bring a circular disk of negative density. I'll place it here. What will get a hole? First of all of you got the diagram. Last sheet able to understand. It will extend to infinity, and this is a field strength what we know it. I'll give the plane diagram. One more diagram will go for it. Here what we'll do is this is the x-axis, this is the y-axis, and this is z-axis. Agree this? So this is a sheet without hole. We'll calculate the field. Field how much on the z-axis it will be. So there's a point. Shall we call E1? Then I'll bring a circular disk. Again, this is x-axis, y-axis, z-axis, and there's a point P. Now, what is this? Minus sigma. There's a hole. There's a disk with negative density. So that negative density, I'll show minus sigma here. Now, how the field due to this should be away, no? Call E2. If you take the superposition of this, what you get? You're going to get a sheet with hole. I think just the same logical thinking, you have to keep on explore it, nothing big. So this resultant field is what is asking here. Now, do we know even? Do we know even? Yes, we know even. What is the formula for even? I think I'll come out to directly this set of diagrams. What is even? Even equal to 2 pi sigma g, or 2 pi g sigma. What is the field strength due to circular disk at a distance 2r? I think the distance is given how much? 2r. 3r, sorry. Field strength due to circular disk. So if you know that what is the field strength due to circular disk, you are on safer side. Otherwise, gone. In exam, you can't derive. Am I right? So I think some minimum memory is needed. So what is the value of this? 2 pi g sigma 1 minus. In place of x, it will be z. This will be r square plus z square. So what is the value of z? 3r. Substitute this. And this should be negative density. Huh? That negative density already I'm showing away. So I'm going to subtract here later on. 1 minus z. This will be z 3r square. So here the z will cancel out. So 1 by root 10. What is the net field at point P? E1 minus E2. So 2 pi sigma G.
Sir,
Ah,
sir, in the bracket it is 1 minus 3 by root 10.
x is 3. 3 will come here, no? So,
Yes, sir.
yeah, here 1 3 will be there. Then how much it will be? 6 will come then. You can expect even questions of these kind also. The cavity means not only spherical cavity. I can bring wherever I want. There's a hole. There's a hole. So what is this? Sheet. Okay, there's our final answer. What should be the direction of this? Towards left, I took positive, no, something. So it will be towards left here. So the resultant field here will be directed like this. So I think what is the basic requirement? You should be ready with formulas. Huh? So what all we derived, it's not like some question. It's a basic requirement. Every student must know what is the thing: field due to ring, field due to disk, field due to sheet, field due to sphere in terms of density and mass, field due to the rod, long rod, semi-infinite rod, semicircular ring, quarter circular ring, or some arc. If you know all these formulas in exams, straight away with that formula you can enter into question. Otherwise, say like, can you derive this? There's a field due to this, no? What is this equation? Due to this. This is due to sheet. So what is this? Field due to sheet with tool. See, even for a teacher also, I don't know formula, what happen? I should derive and waste time. So it's a very much essential that we must have a minimum memory. I'm not asking you to remember plus minus sign, the basic formulas. You go for the mains exam. So what is the ratio of the gravitational field strength at a distance 4r, 2r on the axis of the disk? Tell me what is asking. Put z is equal to 4r, you'll get one value. Put z is equal to 2r, you'll get one value. Is asking that ratio. If you know this formula, you are very good. If you don't know that formula, you can't derive